Hello everyone, welcome back to our channel. In today's discussion, we discuss a very interesting question from the functional analysis part, and this question is asked in the TIFRCAM PhD Mathematics Entrance Exam 2026. Okay. In this question, M is the set. It contains all the elements F belongs to the L2 space such that integration from -1 to 1 f of x dx is equal to 0. And the element gx is given and it is defined gx equal to x square, and this element belongs to the L2 space. And in this question, what is asking, we have to calculate the infimum of this set, and this set contains all the elements of the form L2 norm of g minus f, where f belongs to the set M. Here the L2 norm is defined, the standard L2 norm, it is defined in this way. Suppose f is any element, then L2 norm of f is nothing but -1 to 1 fx mod square dx whole to the power 1 by 2. This is the L2 norm of f. Okay, so we have to calculate the infimum value of these numbers where f belongs to the M. And if you observe it carefully, this is nothing but the this infimum value is equal to the distance of the function g to the set M, and this distance in the sense of L2 norm. Okay, I hope that you get it. Before going to solve the question, first of all, let me give some brief idea how we will approach to handle this problem. Okay, let us take a simple space R2. I hope that you all are well acquainted with this space, and this is the Euclidean space R2 space. Okay, R2 plane. Here the point P is given. Okay, P is the order pair 2, 3, and let us calculate the distance of the point P on the set x-axis. Okay, this is the x-axis and this is y-axis. Suppose the question is here that calculate the distance of P from the x-axis. This distance is nothing but this length. Okay, and it is equal to 3. It is simple. Now I will calculate this distance in a different way. What is the different way? Suppose the x set is defined in this way and the y set is defined in this way, and this is nothing but the x-axis and this is nothing but the y-axis. Then the R2 plane can be written in this direct sum form. And if you consider the set x is equal to M, then y is equal to what? M perp, because these sets are perpendicular. Angle is 90 degree. Okay, here the angle between them is 90 degree. Now if we know that if a set is written in this form, direct sum form, then every element which belongs to this R2 has a unique representation. Means we can find an element belongs to the x set and an element belongs to the y set, and their direct sum give and their sum gives this element 2, 3, and this is representation is unique. Means we cannot find two more different elements which satisfy this. And if we can write an element in this form, and my claim is that the norm of this element is the distance of this point on the set this. Okay, means I am saying that this element is equal to P. The distance of P to the set x or M, x, is nothing but the norm of this element. Suppose it is P1, and it is P2, then the norm of P2, and this norm here in the, because this set R square is also a Hilbert space with respect to the Euclidean norm. Euclidean Okay, and I am saying that this distance of the point P to this set x is nothing but the norm of the element which belongs to the set y, or is equal to, this is equal to m perp. Okay, so we will use this analog to solve our problem. In our question, here the whole space L2 is given, and there is a set given that m. In our question, I have already told about that in our previous part. What is m? M contains all the this set is m. F belongs to the L2 space, L2 minus 1 to 1, such that integration from minus 1 to 1 fx dx is equal to 0. This set is given, and in our approach we will do what? We will write this set L2 in direct sum form m plus m perp. Okay, and g function is given in our question, gx is equal to x square. We have to calculate the distance of the g to m. I am saying this distance is what? Means if we can write g is equal to g1 plus g2, two function, so that g1 belongs to m and g2 belongs to m perp. Okay, m perp is the orthogonal complement. Here in this question, the orthogonal complement of x is equal to y. So x perp is nothing but y. Okay, this is the orthogonal complement. So if we can write an element g is equal to g1 plus g2, where g1 belongs to m and g2 belongs to m perp, then the distance of the g from the set m is nothing but the norm of g2, L2 norm of g2. This is the L2 norm. Okay, L2 norm of g2. This is our approach. Okay, but here the main requirement is this, that we can write this expression when m is closed. It is closed. So first we will show that this set m is closed, then we will calculate the value of m perp. Our given, in the given question m is given, then we will calculate m perp. But before going to show this thing, we have to ensure that this set m is closed, then only we can write this representation, because it comes from the Hilbert space theory. If a set m is closed and it is a subset of L2, then L2 set can be written in this direct sum form. Okay, so we will use this basic idea. Let us move to solve our question. So in our question, m is given this set. Okay, and this set can be written in this inner product form. Here f and 1, because this inner product is defined, inner product of two functions f and g is defined in this form, integration from minus 1 to 1 f of x gx dx. Okay, so if we take f here and in place of g we put 1, so we will get this number. Okay, therefore there is no harm to write this set in this form. Okay, and this is saying what? This set is saying that this set m contains all the elements such that inner product of f with the element 1 is equal to 0, and this is not, this implies that f is perpendicular to 1. Okay, so we are collecting all the elements which are perpendicular to 1, so therefore this set m is this set, singleton set perp. Okay, singleton set, this set singleton set contains the singleton element 1. Okay, so our m set is this one. Now we will calculate the m perp, because our target is to write L2 is equal to m plus m perp in this form. So therefore now we are calculating the m is given this m, we are calculating m perp now. Okay, m perp is if we calculate we will get this one. Here double perp is coming, and there is a very nice formula in the Hilbert space that if A is a subset of the Hilbert space L2, then double perp of A is equal to the span of A closure. So by using this formula we will reach to this step. Okay, and this span of the singleton set 1 is a finite, we know that it is a finite dimensional vector space and its dimension is 1, and we know that every finite dimensional vector space is a closed set, so therefore the span of one closure is itself. Okay, so we get this one is the m perp. But now we have m and m perp, so we are next we claim that L2 is equal to m plus direct sum m perp. But this representation can be valid when it is given that M is a closed set. First of all, we have to ensure that M is a closed set. So in our next target, we have to show that this set M is closed. How can you show it? Closed set means what? It should contains the all limit points. Means if we take a sequence, any sequence Fn which converges to some limit point H, then we have to ensure that H is in the set M. Then only it is a M set will be closed. Okay. To show that M set is closed, we have to show that H belongs to M. Okay. And here Fn belongs to H and Fn are the all elements from the set M. Okay. Since these elements Fn belongs to M, so it satisfies this condition 1. Okay. And we are trying to prove that H belongs to M, means we have to show these things, that integration from -1 to 1 h of x dx is equal to 0. So we start from this expression, modulus of -1 to 1 integration from -1 to 1 h of x dx. Okay. So this modulus is equal with this, because why? Because the integration from -1 to 1 fn x dx is equal to 0. So this modulus can be written in this form, but modulus comes outside. Okay, here. Okay. Then we will bring the modulus inside. Therefore here less than equal to is coming, because the integration of f dx mod is less than equal to integration modulus of f dx. Here this property is used. Okay. So we reach to this step. In this step, in the next step we will apply the Cauchy-Schwarz inequality by taking the element first function to 1 and the second function to this. Okay, this is f and this is g. Then we will apply the Cauchy-Schwarz inequality. So Cauchy-Schwarz inequality or Holder's inequality. Okay, so we will reach to this step. Okay, Cauchy-Schwarz inequality says that if fb integration of fb dx is given, okay, this is less than equal to integration over -1 to 1 a square dx 1/2 integration -1 to 1 times b square dx whole to the power 1/2. This formula I am using here. Okay, I hope that you all are well acquainted with about the Cauchy-Schwarz inequality. So we will reach to this step, and this integration value is equal to √2, and this integration and this quantity is nothing but the fn minus h L2 norm of fn minus h. Okay, but in our question we know that since fn belongs to fn converges to h in the L2, this implies that this norm goes to 0. Okay, so in the next step, if we take the limit n tends to infinity on the both sides, this and this, left and right, but left hand side is independent of n, so it gives this quantity, but the right hand side goes to what? 0, so it gives the value 0, because fn converges to f in the L2 norm. Okay, so therefore we will get that, but this quantity is a non-negative quantity. It is saying that it is less than equal to 0, so this implies that it is equal to 0. Since this modulus value is equal to 0, so this quantity itself is 0. Okay, so we establish that integration from -1 to 1 hx dx is equal to 0. This implies h belongs to the set M. Okay, therefore our set M is closed. Hence we can write this L2 space in this direct sum. Okay, M plus M perp. And in my previous discussion, I have already told that told about this distance. This distance is the L2 distance of the function g on the set M. Okay, and g is defined in this way. And so this is nothing but the projection. If we will project this element g on the set M, our target is to calculate this length. Okay, I have already told that if we can write g in this form, where this element belongs to the M and this element belongs to the M perp, then our required distance is the L2 norm of this. L2 norm of FL vector. Okay, so this is our required answer. So yes, therefore we will write here we given that g is in the L2 space. Okay, and our M is what? Our set M, M contains M contains this set is M, but and M power p is what? Here we have already calculated M power p is span of 1. Okay, it will be used. So in our question, okay, this is the M power. Okay, suppose G is equal to G1. G1 belongs to G1 plus G2, and G2 belongs to what? M power. But M power p is the span of 1, so G2 is equal to what? C times 1. C is some real number, so this one is coming. Our G2 function is this one, C times 1. Why C times 1 is coming? Because our set G2 belongs to M2, and M2 is the span of 1. So therefore M2 contains the scalar multiple with 1, so it gives this element. Okay, I hope it is clear. So our answer is what? Our answer is the L2 norm of this element, C times 1. C times 1 is equal to C. So therefore our answer is, if we calculate the value of C, then we will get our answer. Okay, so in our next step, our target is to calculate the value of C. Okay, but the L2 norm of C, L2, not the value of C, L2 norm of C, L2 norm of C, this is our answer. Okay, but before that, first of all, we have to calculate the value of C. Okay, so next, since G is equal to this one, then we will take the inner product of G with a 1. Okay, since G is equal to G1 plus C, so we put this value, and since the inner product is linear, it can be written in this form, and we know that G1 belongs to what? M. G1 and G1, since G1 belongs to M, and M contains all the elements which are perpendicular to 1, so G1 is perpendicular to 1, so therefore this inner product value is equal to 0. Okay, and this inner product is kept as it is, and by using the definition of the inner product, we will get my integration minus 1 to 1 C times 1 dx, and if you calculate this gives to C. Okay, therefore the value of C is equal to half times inner product of G comma 1. Okay, and if you solve this inner product value, Gx is equal to what? X square, so it gives this one integration, and after calculation you will get the value of C is equal to 1 by 3. And I have already told that the L2 norm of C is our required answer. Okay, and you know why this is our answer, because this is the orthogonal projection, this length, this is equal to C. Okay, and this length of C is equal to our answer. Okay, and the length of C is nothing but the L2 norm of C. Okay, so if you calculate the L2 norm of C is defined in this way: C square dx whole to the power half integration, and in the integration is taken from minus 1 to 1, and since C is equal to 1 by 3, so C square gives 1 by 9, and it is a constant quantity, so it comes out, and integration from minus 1 to 1 dx is equal to 2, so 2 by 9 is coming, and whole to the power half is there. So after simplification we will get it is equal to root 2 by 3. Okay, so this is our required answer, root 2 by 3. So our answer is root 2 by 3. So option A is true, and these all are false. Okay, I hope that everything is clear, and you all enjoyed this explanation. Thank you all. Bye bye.